Welcome. I'm glad you could join us with such short notice. We had technique problems yesterday, and this was nothing that we could do something about, since the live event wasn't possible to show at that time. So hopefully everything will run smooth today then. I will start by just presenting a little bit what we will go over today. My name is Jonas Wikner, and I'm the marketing manager here at Haglöf. We will talk about the Vertex Laser Geo instrument and the function, the special function map target in the Vertex Laser and the Laser Geo to measure irregular objects of any material. And this presentation will first go over the hardware, briefly what sensors the units have, and then talking about the menu system a little bit, going into describing a little bit about the project background, how we have come to the measuring method for use of okay. Sorry for that. Det här är inte. Får kolla, Patrik. Okay, sorry for that. So in the end, we will also show a short video explaining how this inventory is done, and it can be of any material. It could be wood chips, it could be any irregularly shaped object. Okay, so we'll start with to go through the sensors of the unit. You have the orange one is the Vertex Laser, and the Vertex Laser combines two measuring methods, and then you have the blue one that is the laser you see on the picture. But they both are the same except for the ultrasound. So there is a built-in tilt sensor that has an accuracy of 0.1 degree, and that makes all of the different measuring that we do in the unit possible. So we always capture the angle or the slope when measuring distance in all the different functions. Then both units have a precision laser that can measure from about 50 centimeters up to 600 meters with plus minus 4 centimeters accuracy. The Vertex Laser, the orange unit, has ultrasound, and ultrasound works with the speed of sound. So the difference here from laser is that you have a reflector, a receiver that we call transponder T3, and the time is measured for the sound to travel two ways. The maximum distance is 30 meters, and you can measure from about 10 centimeters up to 30 meters. Ultrasound is superb when working in when you have dense areas, a lot of branches or undergrowth, like conditions in the forestry, but also other branches where you don't clearly see the target. There is a built-in compass sensor, and the compass is at plus minus 1.5 degree accuracy, and it's fully integrated in the unit. and also brought in, for example, in the function that we will go through today, especially in the map target function. Then there is a built-in GPS receiver, and this receiver makes it possible to position where you are standing in relation to the target. Then you have a SSD drive that's also built in, so you can actually store locally in the unit all your measurements. It has the Bluetooth 4.0, and this newer version of the Bluetooth, or newer Bluetooth, also works much longer range than the traditional one that you might have used before. That older type was maximum 10 meters and in a condition where you don't have, like in a room, but this one works, and we tested up to, let's say, 50 meters is normally not a problem, and it's much more secure connection. Then you have USB, so it's a full USB, so you can both charge the unit over the USB, or you connect it to your PC and you can send files. And the unit will be like a disk drive when you connect it to a PC, for example, so you don't need any external software to extract the files. It will be like a disk in the computer. You have a rechargeable built-in battery that is fully charged after 3.5 hours. You can charge it on your laptop as well. It will take a little longer time. So if to get the fastest charge, it's by the wall plug. But you can also charge it in the car, or you can have so-called emergency charger if you are in the terrain working over a longer time. But normally, a couple of working days is never a problem, even when it's cold. But it's, of course, you should charge it after a working day. It's a graphical LCD display that we also have on other models like the Vertex, for example, and it's very visible to see the measuring results on the side of the unit. It's a heads-up OLED display where you directly in the scope of the instrument see the distances and the angles and all the results from the measurements. So you see them both on the graphic display and inside the scope. The functions that we have in the unit is the 1PL, as you see on this presentation, and this function is used to know the height difference between you and the target. Here it's important to know that the eye height that you can set in the unit will be added. So for example, if measuring and you are setting 1.6 as your ref eye height, then it will measure from your eyes to the top to the target and add the eye height. And this could be if you want to know the difference in height, for example, between your location and a mountain or a treetop, the 1 point. Then we have the 3 point, and that is to know the actual height of the target, where it's standing. So you measure the distance to the target, and then you measure the angle to the bottom and the angle to the top. This is the most used for forestry. Then we have the 3D vector, and this is giving you all the vectors in the, so you get all the vectors for a target. You can get the length, for example, instead of the height of, if a tree is leaning, this would be the function to use, or to know the green crown, etc. How wide is the green crown? Then you have the height DME, and that is using the ultrasound. So this height DME is only available in the Vertex Laser. So that works just like setting up the transponder, measuring the horizontal distance to the transponder, and then the angle to the top, and it presents the heights. And all of these functions we have had a special webinar for before this. Then you have the built-in compass. You have the angle measurement, and the compass is just a compass menu to see the bearing. You can set 360 or 400 gone. Then you have angle measurement, and that is just to see the slope in the terrain, or slope measurements, and you see it in the scope as well, not only on the side. And we have the map target function that we will go over more deeper today. And in the map target, you can also not only measure three-dimensional, but you can also measure an area, for example. If you want to know how many acres is this clear-cutted area or a parking lot or something like that, you can use the map target. You have a map trail function to, if you're going to do a forestry road or something like that, logging a path with the sensors, you should use the map trail. Then we have line clear function, and line clear is for power line business and to know if a tree will fall on the power line or not. And then we have the delta height, and that is to know the straight line between two poles down to the maximum sag of the line. And these functions has also been in a special presentation before this, the line clear and delta height. So to explain a little bit before we go into the method, I want to mention about how we have done in the background of this project, how to measure irregular piles of wood chip or gravel or anything like that, because it's very hard to measure. It's a lot of different things that the result depends on. And we started already 10 years ago a project with a customer of ours here in Sweden to try to get the volume more accurate and with a better accuracy, consistency of these irregular shaped wood chip piles. But at the time when we started these tests, there weren't many good options, and many of the hardware solutions that were available for us to use weren't that reliable, and it was always about connecting different instruments to each other and so on, and we run into quite many problems. But at that time we made also a project of measuring roundwood piles, bigger piles of roundwood. So that's how that project also started. You know, we have a solution for that as well. But when we introduced the Vertex Laser and the Laser Geo late 2017, that was on Elmia. After that, late 2017, 2018, we went back to the customer and asked if they were interested in a project trying to again find a way of measuring these irregular piles. And we started together with them a project, and we bought a drone as reference data, and we because we needed to know what is the result of from the measurements to be able to compare. And just to mention, during this project, we found out a lot of things that was very useful and good for us. And for example, I can mention that what we found out, it's very good. The Laser Geo, it can be used even if it's any weather condition. There is one thing that might be a problem, and that is a problem, and that is if you have if it's very foggy or mist in the air, laser can detect that. So that's a problem but that's probably the only thing that we run into. You can measure if it's cold, if it's raining, anywhere. It doesn't matter because the unit doesn't depend on connection with the GPS. So you're really free to use it in remote place, that it doesn't have to be on the industry and so on. And you can use it with gloves if it's cold. Then it's an all-in-one unit, so we noticed that you can measure with only the laser itself, and you store the result, and when you have done all your measurement, you don't need to connect to separate units, and that was very good. If you compare, for example, we flew with a drone, and that worked well many times, but at the industry, for example, there are restrictions against flying, against sometimes to take pictures. You have wind conditions. If it's snowing and if it's raining heavily, it wasn't possible to use the drone. And maybe the main advantage with the Geo is that it doesn't need, you can get immediate results still being on the industry or at the forest area where you have your pile. You're not obligated to upload. For example, what we used was services where you upload your images, and it's quite heavy material from the drone. So at one point we went on a pile, we measured, and it was 400 kilometers one way to drive down there, and we did measuring all day, comparing data. And when we came back, we uploaded the images as reference data overnight. And when we came back in the morning, some of the images were missing because of strong winds. So we couldn't get any comparable result. So this is something to think about also. With the Geo, if you have done anything wrong, you will know it immediately, still being on the spot. So that's a big advantage we noticed. Okay, so the method that we finally came up with after, I think it was about 6 months, was verified by the customer of ours, and that is the independent control measuring organization here in Sweden that measures all the timber at the industry. And what we found out was first important is that any compass should be tested, because a compass gets problems if you have metallic objects in the ground, or if you have your cell phone too nearby in the pocket, or car keys or something like that. And our compass can be calibrated, of course, and you can also set in the unit the magnetic declination for the area where you are. But we don't recommend just to calibrate the compass, because we do a factory calibration here. It might be something else that is wrong with the unit. So you see there also, we have in this project, we took, and we have our own magnetic, non-magnetic monopod. So we know that this is very important, that if you use just any monopod, for example, it might be problems since the monopod itself is disturbing the compass. But our monopod we supply with the unit is non-magnetic. But we developed a test function for the GPS, and this just tests the accuracy of the GPS at the position where you are. So how that works is that you measure in one direction to a clear target. You go to the test function, obviously, in the settings menu, and you measure. And then you go to your target and you measure reverse. And you should be, as it says in the presentation, 180 degrees plus minus 4 degrees. Then you can say that, okay, there is the conditions to measure where I am is good enough. Then you don't risk that you do all the measurement and the data is crap. So this is an important thing that we found out. And you can also do these tests because it's very fast to do them. So you can do it a couple of times. And how this method works then. First you come to the area, you test the compass, then you start planning your inventory, how I would like to perform my inventory. If you see the pile here, you take a walk around and you see from where or where do I have to put my reference points. And I plan in sections. So a section should not be wider than 90 degrees from my reference point. And I need to see my next reference point from the one where I'm standing. So these are the conditions for the planning. And then I just put out as many reference points as I need. And you also have an option, and we see that you're much faster if you use the autosave in the unit. So when you measure a point, it will automatically store and you hear a signal when the point is stored, rather than having to send the point to the memory. But you can choose in the settings if you want to store or send the value, or if you want to automatically send the value. So you put the cones out where you want to have your reference points and where you best can cover the target, and then you can start your measurement. So now I am at my starting point, my first reference point. And when I take my first measurement, this is the method that we found out from a lot of testing, was to start from left to right and to measure base points first. So when I start the instrument and I want to start to measure, I will first aim on the left side of this section. You see the yellow line on the left where it goes down, that's to mark where the section starts. I will measure my first point, but then the instrument will prompt for a GPS position of my location. And this is only at the first reference point. On the other reference point, it doesn't need a GPS position, and the unit actually doesn't need a GPS position at all to get the volume. This is just to show on a map where is the pile, but the volume will be the same no matter where in the world it is. So this is how it goes. I measure, and it auto saves my measurements, and we say like 6 to 10 points, depending on how irregular the pile is. Then I aim about half a meter up, and I do my second line of points. And this is a kind of security line that we came up with in the method as well, because if I didn't take this point, we risk with the method to overestimate the volume, because actually the calculation that we use is the nearest grid, called the nearest grid. It's a quite advanced mathematic form to calculate volume of irregular objects. And if you have your second line, let's say 2 meters up, it will draw a line between those 2 points. And if it's air there, or you miss your base point, don't see it clearly, you will overestimate the volume. I will show in a calculation. And then I continue with third line, and I measure where it's changes in the contour of the pile, and then I measure the top contour. Like that. And now I am ready with my section. I will go escape on the unit to tell the unit that I'm done with my section, and the unit will say new reference, and I will say yes, and then I go or measure to the next reference point, and I will show that. One thing also that is important here in the beginning, when you measure your base points, after measuring your base points, you should press escape at the final base point, the red dots. When you're ready with your base points, you press escape and tell the unit that the other points are on the pile. And this is an important thing for us, just for the calculation afterwards. So I forgot to mention that. But first the base points, and then escape one time to start measuring on the pile. Okay, so this shows measuring the section. And now you see to the left, you have your next reference point. I have told the unit new reference, and then I measure on the reference point, and we suggest to measure and get the same result 3 times for the distance, because you might risk to miss and hit the target on behind, or it could be a car standing nearby that you hit or something. And if you have the wrong, if you move to the wrong position, it's of course the data will not be correct. So I measure and I walk to the second reference point, and it's important to stand exactly on the point. So you move the cone and you stand exactly straight where you were measuring. And then you measure your third point. The same. And the last reference point, cover with base points, and then the points on the pile, describing it as well as you can. And then finally you measure back to your starting point. And then when you press escape, you will tell the instrument that now I'm ready with the measurement. And just going back to this project, what I spoke about, we did a lot of measurement on different type of material, different times of the year and different shapes and big and small and so on. But this is one bark pile that we measured. You can see the drone as we used as the reference had a volume 8,050 cubic meters, and this was quite early in our project. We adjusted some things after this as well, but there were done 3 different measurements by 2 persons at the same object. And you can see the volume result, the base area, and for example, the average heights. You can see they vary very little there. So it was a quite consistent result that we got. And also you can see what I was talking about, the half-meter line that we came up with. If I would take away the middle point there, actually it will be represent a quite big portion of air, and that was in our calculations all the time 3% that we overestimated if we skipped that half-meter line, naturally depending on if the pile is regular and easy to see and so on, but 3% on an average. And the pile you see to the right there is the one that was described in the data before with the drawn image. You can see that the machine has been driving on the pile as well. Okay, so this was describing the method, how you should work, and it's important that follow this left to the right and so on. I was going to show a small movie about everything that I spoke about now to get a better view of what I was talking about. Okay, so now the compass have been tested already to know that there was no conditions in the ground or concrete or something that disturbs the compass. I go out and start planning my inventory, putting the sections out so that they are not, you don't cover more than 90 degrees. You must see the next reference point from the one where you're standing. So that is also important. And it's also something to think about, that not trying to overlap. So what you cover from one point, the reference point, you shouldn't cover from the next reference point. So now you're at the first point, measuring, starting to the left and measuring the first point, and it starts the GPS automatically and starts to log, and you see number of positions and you see how many satellites is found. And then when you're satisfied with the data, you press on to store the first point and your position. And remember, this position is only important to show, to create the KML file. Then you measure and autosave base points. And it goes very fast and smooth, and depending on how irregular the pile is, you should take more or less points. Then you press escape to tell the unit that now I'm no longer measuring base point. I'm starting with my points on the pile. And this is because it should calculate the base area from the base points. So you measure your security line at ½ meter, about. It's not important that it's exactly ½ meter. It could be anything nearby there, but about ½ meter. And in this case, a third level, a third line, where the pile changes, and then the top contour is measured. You see all the time, you see the result in the scope. Now the section is ready, so you should move to the next reference point. But first you press escape to tell the unit that now I am ready with my reference point. Aim at the second reference point and repeat 3 times the result, aiming at the base of the target. Here it's important if you're, for example, 2 persons and 1 person is the target, then you should aim at the feet and not high up on the shoulders or something, because that will actually destroy the data. Then you would need to stand on the shoulder of a person on the second. We did that at one of the testing. We had the customers that used each other as targets, and that is not recommended. Then always shoot at the feet. So I am at my second reference point. I measure from left to right, not covering more than 90 degrees, and I try not to overlap. Measure my second point, my third point, and so on, until I covered everything. And then in the end, I measure back to my starting point, my first reference point. And then I escape. And go to finish. And now I'm ready with my measurements. So now I have all the data stored in the Geo for this pile. And to see the result now, I can see it actually, and this is what I talked about earlier in the project. One of the problems was with, for example, we ran into with the drone, was that you couldn't immediately know if the data was correct or not. Here we have our possibilities. We have the Hagelhoff link, that is an app that is free for download on Google Play and App Store, where you can take the files directly from the Geo. And the Geo, as you know from previous presentations, stores a KML file and a CSV file. And the KML file is the file used to show on a map, and the CSV file for all the calculations that we are doing. But you can easily then, over the Hagelhoff link, take the files out. And I will show a film of this, how this is worked. And also we have a cloud solution for this called Pits and Piles that Hagelhoff offers. And this is a new thing that we have now. So, short film. First of all, you have the app that you download, and then you go to the handling the files and start receiving the data. And in the unit, once I have the device connected, I go to the settings. And I scroll down to send files, and I press on in the unit, and it will start to transfer my measurements. And imagine now you can still be standing there by the pile with this solution. Then I have my files, and they are sorted in this case by date, if I have a lot of data in the unit. So I take my KML file, and if I have the Google Earth, I select that, and it will automatically zoom in on my measurements. And from this, you cannot see the volume or things like that, but you can verify that it looks good and you have no errors. It looks good, but to really be secure, you need to upload the CSV file. In this case, if I have the pits and piles solution and an account there, I will upload my data to the pits and piles. I give it a name of the file. And just to mention also that it will be a presentation. The next presentation we will have will be around this solution, around Haglöf Inc. and our cloud solution Pits and Piles, more deeper in details what you can do and so on. But in this case, the CSV file is uploaded and you can see the image. You can select a lot of things. You can also create a report of the volume and all the measurements. And if you are not using the Haglöf link, you rather go back to the office, you could, this shows going over the PC then. So you go in, you have an account already. So you have the Haglöf application cloud, and under there we have our services, and this is Pits and Piles that we have now. So you upload, you connect your unit then by USB, the Geo, and you select the files and upload them to the cloud service in your account. So in this case, I select the VLGeo, I take the CSV file and open it. And this is my measurements, and you see there is something that looks really strange. I clearly missed one of the top contours and hit the tree in the background, but here you don't need to worry. It's very simple to erase a point and to correct the data. So in this case, zoom in, find the point that is obviously missing and take it away, and boom, I have a good sized that looks like the pile was looking. And here also you see you can do some things. You can change the color of the pile, for example. You can look at your measurements, set some calculation, the factor you can set. You can take a snapshot of the current view and create a report from that, and we supply a standard report here. And this Pits and Piles is a free version, free to use, but if you want to store data or if you want to create results like you will see now, let's say you're doing your measurements in January and you want to compare it with the measurement you did in December and November. That what you see now here is 4 measurements that has been done on the same pile. If you want to create reports like this, then it's a payable version of this cloud solution that you need. And you see here, for example, you see how the pile varies over time. And this is not available in the free version, and you cannot store any data, but you can, of course, print your PDF or something like that in the free version. But this will be a separate presentation going more deeper in detail about this cloud solution that we offer, and also the Haglöf link. Okay, so this was what was planned today. I hope you found it useful. and that it wasn't too much information for you to get in. I think it's the method that we have is very hands-on and very easy. But you need to test it and to go out and do it in the field, of course. And if you have questions, get back to us, and we'll try to answer them in the best possible way. And it's always good if you get back with any question that you have, because it might be something that we haven't thought of either. Thank you very much for listening. So next presentation will be about HagofLink and our pits and piles solution to what you can do there. Thank you very much.